Hello and welcome to the video on proving lines parallel. If you have not yet watched the previous video in the series, which is on angles and parallel lines, I would strongly suggest going back and watching that video first. In this video, we are going to talk about the converse of a couple of different theorems and postulates we've already talked about. To understand these new theorems, we need to know what the converse of a statement is. The converse of a statement is essentially when you switch the hypothesis of the statement, meaning the first part of the statement, and the conclusion of the statement, or the second part of the statement. I think this is easiest seen with an example. My example here, if I have the statement, if today is Monday, then tomorrow is Tuesday. The hypothesis here is the if portion here. That's the today is Monday. The conclusion is the then portion of this. It says tomorrow is Tuesday. So when I'm writing the converse of a statement, I'm going to switch these statements, hypothesis and conclusion. So originally this said, if today is Monday, then tomorrow is Tuesday. Well, the converse of that is going to say, if tomorrow is Tuesday, then today is Monday. Notice how the part that was once the hypothesis is now my conclusion, and the part that was once the conclusion is now the hypothesis. They've switched locations. Now that we know what the converse of a statement is, we can look at the converse of the corresponding angles postulate. The corresponding angle postulate said if the lines were parallel, then corresponding angles were going to be congruent to each other. Well, the converse of that is going to switch those two parts around. It's going to say if two lines in a plane are cut by a transversal so that the corresponding angles are congruent to each other, then that's going to show that the lines have to be parallel. So in our picture here, I have two lines, Q and R. I don't know whether or not these are parallel yet. I'm trying to show that. If I can show that two corresponding angles are congruent to each other, in this case angles 1 and 5, then that would show that lines Q and R have to be parallel to each other. This is saying if you can show these angles are congruent to each other, from there you can conclude that the lines would have to be parallel. The alternate exterior angles converse is going to say if you can show that two alternate exterior angles are congruent to each other, that would be enough to show that you have two parallel lines. So in our case, if I can show angle 1 and angle 8 are congruent, I would know that lines Q and R would have to be parallel. I could have also used angles 2 and 7 because they're another set of alternate exterior angles. The consecutive interior angles converse says that if I have two lines in a plane that are cut by a transversal, if I can show that the consecutive interior angles are supplementary to each other, then I would know that these lines are parallel. So in other words, if I can show that angle 3 and angle 5 add up to 180, then line Q and R would have to be parallel to each other. And the alternate interior angles converse is going to say if I have two lines in a plane, again cut by a transversal, that makes a set of alternate interior angles congruent to each other, then I know that those lines are parallel. So my alternate interior angles here, angles 4 and 5 for example, if I can show that they are congruent to each other, I would have enough to show that lines Q and R would have to be parallel. The parallel postulate says, if given a line and a point not on the line, so in our case, that's line L and point A, which is not on line L, then there exists exactly one other line that goes through point A that is parallel to the given line. So our new line here, line N, is the only possible line that goes through point A and is parallel to L. The converse of the perpendicular transversal theorem says, in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So in this picture, if I have two lines, L and M, that are both perpendicular to line T, then these two lines have to be parallel to each other. This is because of the converse of the corresponding angles theorem. These two angles here are corresponding, so if they're both the same size or both 90 degrees, then these two lines would have to be parallel to each other. Let's try a few examples here. Given the following information, we want to determine which lines, if any, are parallel. Part A here says that angles 2 and 6 are congruent to each other. Well, I notice that those are corresponding angles. Since my two corresponding angles are congruent to each other, I know that the two lines that they're on, in this case lines K and L, would have to be parallel. Part B, angles 3 and angle 10. Well, angles 3 and angles 10 are alternate interior angles. If alternate interior angles are congruent, that would make lines K and M parallel in this case. Part C, if angles 7 and 9 add up to 180 degrees, that would make lines L and M parallel to each other because angles 7 and angles 9 are consecutive interior angles. And the last one, part D, if angles 3 and 4 add up to 180 degrees, well, those are just a linear pair. They're not on any separate lines. So this is one of those cases where we need to make sure we have read carefully. It says which lines, if any, are parallel. In this case, we would say that there are none. Let's try the same thing again with a little more complicated picture. Example number 2, given the following information, determine which lines, if any, are parallel. Part A says angles 3 and 10 are congruent to each other. Well, angles 3 and 10 are both on transversal C, and they are alternate exterior angles. The converse of the alternate exterior angle theorem said if I have congruent alternate exterior angles, that would make my other two lines, in this case lines A and B, parallel to each other. Part B, angle 4 is congruent to angle 6. Well, those are consecutive interior angles. The converse of the consecutive interior angle theorem said that the consecutive interior angles had to be supplementary in order to make these lines parallel to each other. Well, in this case, they're not supplementary, they're congruent to each other. So in this case, there are going to be no lines that are parallel to each other. Part C, angle 6 and angle 13 add up to 180 degrees. Well, those are consecutive interior angles. In this case, they are supplementary. So since they're both on transversal D, that would make lines B and A parallel to each other. And part D, angles 4 and angle 12 are congruent to each other. Those are corresponding angles. They're both along transversal C, which would make, again, lines A and B parallel to each other. And two more problems here. We're going to attempt to figure out the value of x to make these two lines parallel. Problem number 3, I have angle 1 equal to 8x minus 20 and angle 8 equal to 4x plus 40. Those two angles are alternate exterior angles. So in order for me to say that these lines are parallel, those two angles would have to be congruent to each other. To make them equal to each other, the 8x minus 20 would have to equal to 4x plus 40. I can now solve for x by combining my like terms. I can do that by subtracting my 4x's. I get 4x minus 20 is then 40. I can then solve for x by adding my 20 over and then dividing by 4. This gets me x is 15. I can quickly double check if I did the problem right by plugging the 15 back in. 8 15s would be 120 degrees. Minus 20 would be 100 for the measure of angle 1. For the measure of angle 8, I would do 4 15s, which would give me 60, plus the 40, which is also 100 degrees. Since they did indeed turn out to be the same size, I know those lines would have to be parallel to each other, so the answer of x is 15 is what I want. Let's try example number 4 quickly as well. Angle 5 is 8x minus 5, and angle 3 is 5x minus 10. Looking at my picture, angle 3 and angle 5 are consecutive interior angles. In order for me to say these lines A and B are parallel to each other, those consecutive interior angles would have to add up to 180 degrees. I can then solve for x by combining my like terms again, adding the 15, and then dividing by 13. This gives me an answer of x is 15 again. Now both my answers here for problem 3 and 4 turned out to be 15. That will not always happen. We can again double check our work. If I plug it back in, 15 times 8 is 120. When I subtract the 5, I get 115 degrees. And 5 times 15 is 75. Minus 10 would be 65 degrees. Those two angles are indeed supplementary, so we know we got our problem right.